In the 20th century, it's like a time in our history that we have like many conflicts regarding scientific, arts, economics, politics, geopolitics. So we had wars, we had new countries to appear, but we start now talking about the science. Okay, we talk about science. And in the 20th century, we had a lot of new discoveries in science. But to make it more easy and more simple, I will just work with two main important persons, scientists. That one is Albert Einstein. And the discoveries of Albert Einstein was very important, like the relativity theory. Okay, so the time and space is not independent. And we also have Heisenberg working more closely with quantum mechanics and say, oh, it's hard to know where a subatomic particle will be. And that's what we call principle of uncertainty. We may know probably where a particle is, but we cannot say for sure. But we'll say this in the subatomic view. But a new level of reality appear for us. And in some way, we start to think in new approaches to deal with our reality. Because it starts to see that the world was not a clockwise. It was pretty more complex than we thought. So we start changing views of the world. We starting to build new theories, new approaches to understand our world. And there are more important persons here. And one that I would like to highlight is Bertalanffy. Okay? Bertalanffy brought us what we call general system theory. Okay? Bertalanffy was in fact a biologist and he was studying living creatures, living systems. And here there is a citation from Bertalanffy that I read and then we'll discuss. He said, it's necessary to study not only parts and process in isolation, but also to solve the decisive problems found in organization and order unifying them, resulting from dynamic interactions of parts, and making the behavior of the parts different when studied in isolation or within the whole. So here you can realize that Bertalanffy was in a such way disagreeing with Descartes, Newton, and Laplace mechanics view of the world. He said, no, I mean, I think that we may we should think a system from different parts, okay, but if we study a single part, this single part will have one behavior, but as soon as this part is interacting with another part, the behavior will change. And we can think in this in different parts of our body. We have different organs, okay? But we will also have what we call systems, that it's the combination of different organs. And with we understand just one organs, we will understand the organs, but the organs is part of the whole, and the others organs will in some way influence the behavior of one organ. For example, when you are sick for, I don't know, it could be an illness, the doctor could give you medicine that you take, and it will fix one organ and then starts to cause undesirable effects in another organ, because everything is connected. And here what Bertalanffy is saying. Again, making the behavior of the parts different when studied in isolation or within the whole. So, what Bertalanffy is arguing is that the reductionism is not enough to deal with the systems. And we can think systems as many things in our reality. We can think our body as a system. We can think the global economy as a system, okay, with different parts, where you can understand each part as one country and how they interact. We can understand a company as a system. We can understand a soccer team or a basketball team as a system. So if you look, for example, to a single player, he will play in a such a way. If he is playing like alone during the training process, but he will be part of the whole. He will be part of the system that is the team. Okay, so that was the contribution from Bertalanffy. He was biologist, okay, but we also had contributions from psychology, and here I have Max Weinheimer. He helped to create the Gestalt theory of Gestalt, or Gestalt theory. Not alone, but I just brought his like as the explanation of the Gestalt. And he said here, there are wholes, the behavior of which is not determined by that of their individual elements, but where the part processes are themselves determined by intrinsic nature of the whole. It's the hope of Gestalt theory to determine the nature of such wholes. And here he was not discussing about like the human body or the organs, but he was discussing about the psychology process, especially for perception, and say, oh, okay, sometimes there is part, and the interaction of this part will like help to emerge a new behavior. And we needed to understand this emergent whole. And here I have one example. Oops, that's the Gestalt example. In the Gestalt theory, there are a lot of laws. Okay, here I just brought one law. That's called law of closure. And here, if I ask, what are you seeing in the screen? You'll probably say, oh, a triangle. Okay, but I can tell you, this is not a triangle. Okay, it's like three circles with a cut in this way. But the perception is like confusing us. We see the triangle because we close the lines. Okay, that's why we call this law of closure. It's closing the lines. But in fact, it's not a triangle there. Actually, there are three circles with this incision, with this cut. And it's in some way we can see and perceive a triangle. Okay, so here we have the combination. If I take just one circle from the picture, you will not see a triangle anymore. So it's exactly the combination of all those three triangles in this position that will cause to emerge the perception for us of a triangle. All right, so this is one example from psychology. Again, it's some way put the mechanistic way, the reductionism at risk, because here we can understand each part. I can understand the circle, etc. But I cannot say, looking just to one part or just one circle, I cannot predict that it will cause us to perceive a triangle. That's one example from psychology, from perception. And here I have one example, like if I have an elephant, I can put different persons, like blind persons, to touch. And they are touching the same object, in this case an elephant. But each person is feeling, is perceiving different parts of this elephant. One can say, oh, I think that it is a tree, or maybe it's a hope, maybe it's a snake. And even if they talk to each other and discuss, probably they will not figure out that it is an elephant. And that effect is what we say that the whole is greater than the sum of its parts. The whole is greater than the sum of its parts. Because here we have different parts, but every part, if we sum together, we will not identify an elephant here. As we saw here, if I study all those elements, all those circles, I will not see this big and white triangle. Alright? Because the triangle is more than the sum of the parts. Alright? So, quiz time to discuss all those topics.